The synthesis of cinnamaldehyde. Attention! In this synthesis hazardous chemicals are handled. I don't take any responsibility for damage done to persons or property caused by the replication of these experiments. The apparatus consists of a hot plate with a magnetic stirrer, a three-necked round-bottom flask with stirring bar and a thermometer, a Dimroth condenser, and a pressure equalizing dropping funnel. First, 35.4 grams of benzaldehyde were added to the flask. To this 70 milliliters of methanol were added. Before addition of the next compound, the condenser and hot plate were turned on. Then 14.7 grams of ice-cold acetaldehyde were added. This has a boiling point of 20.2 degrees C, which is why even opening the container at room temperature can cause a flash boil. Ice was added to the cooling water to make sure the acetaldehyde is not able to pass the condenser. The flask was also cooled with an ice bath due to the slowly rising temperature and because it had to be cooled to 10 degrees C afterwards. To the dropping funnel, 5.6 milliliters of 15% potassium hydroxide solution were added. When the mixture had reached 10 degrees C, the potassium hydroxide solution was added in small portions while the temperature was watched carefully. The first drops didn't cause a significant rise in temperature, so a few more drops were added. After that, the temperature rose slowly, but only by 2 degrees C. Due to the small rise in temperature, the ice bath was removed. Otherwise, this could lead to the hydroxide solution being added completely before the reaction unexpectedly begins. The heat of the reaction could then be released very quickly so that the cooling would be insufficient. This is called a runaway reaction. Then the hydroxide solution was added further. On the dropping funnel, a colored compound was formed which might have been fumes of acetaldehyde reacting with the hydroxide. While the hydroxide was added, the solution slowly became colored. To the cooling water, more ice was added occasionally. After the addition, the mixture was stirred for 3 hours at room temperature. Acetaldehyde is a CH acidic compound and can be deprotonated by a base, which leads to the enolate. This can act as a nucleophile and attack the carbon of the aldehyde group in the benzaldehyde. The charged aldol is protonated and the uncharged aldol is formed. The aldol loses water and an alpha-beta unsaturated carbonyl compound is formed, which is cinnamaldehyde. While stirring, the color became deeper and the smell of acetaldehyde was barely noticeable. Instead, the mixture had a distinct smell of cinnamon. That's why the reaction was stopped after 3 hours. Next, the pH was tested, which should be alkaline. The mixture was neutralized with glacial acetic acid. After that, a mixture of benzaldehyde, acetaldehyde, cinnamaldehyde, methanol and potassium acetate was present, from which the cinnamaldehyde had to be separated. The mixture was added to a beaker, and the flask was washed out with water. Then it was stirred. The water should remove water-soluble compounds like potassium acetate, methanol and acetaldehyde, while also causing the layers to separate. When the stirring was stopped, a mixture collected at the bottom, which was mostly cinnamaldehyde and benzaldehyde. Then another 30 ml of distilled water were added and the mixture was stirred again. Next, the mixture was added to a separatory funnel to separate the layers. The volume could not be predicted, so the water was added in a beaker, but here it can be seen that this step could have been done right in the separatory funnel. The beaker was washed out with distilled water. The funnel was swirled to get the drops that stuck to the wall to go down. After that, the organic layer was added to an Erlenmeyer flask. It was opaque due to traces of water, which was not a problem because it was going to be dried later on. The flask was set aside and replaced by an empty one. The watery layer was extracted with diethyl ether. As an alternative, MTB ether could be used. The amount was not mentioned in the source, so 10 ml were used at first. After shaking it, the layers did not separate very well. So another 10 ml of ether were added, leading to a total of 20 ml. When extracting with ether, it's important to equalize the pressure frequently. After some shaking, the pressure doesn't increase as much. Nevertheless, there was still no good separation of the layers, so a large amount of sodium chloride was added. The sodium chloride dissolves in the watery layer and increases its density. This leads to a quicker and better separation. The exact amount is not important, and due to the high solubility, a fairly large amount can be added without saturating the watery layer. Even an excess on the bottom is not a big problem. To see if the excess dissolves, it was shaken again afterwards. Then the layers could be separated. The watery layer was added to a large Erlenmeyer flask and the organic layer was added to the other organic mixture. The watery layer was extracted again with 20 ml of diethyl ether because the yellow color was an indicator that it still contains some product. The watery layer was discarded and the organic added to the rest. Here a mistake was made because the organic layer had to be washed with water to remove water-soluble traces of sodium chloride, methanol and potassium acetate. Then the organic layer was dried with anhydrous sodium sulfate and left overnight. The amount depends on a lot of factors, which is why usually enough sulfate is added until it doesn't form lumps and flows freely. Also the movement as in a snow globe is a good indicator. The flask was closed and left to sit overnight. It can also be checked after 15 minutes if the mixture is dry, and if not, more sulfate can be added. Next, a simple distillation was set up with a hot plate and magnetic stirrer, an oil bath, a round bottom flask with a stirring bar, a distillation bridge, a thermometer that shows up to 250 degrees, and a receiving flask. Then the sodium sulfate was filtered off and the filtrate collected in the distilling flask. The Erlenmeyer flask was washed out with some diethyl ether. The flask was attached and the oil bath filled up. The receiving flask was cooled with ice because diethyl ether was going to be distilled off first with a boiling point of 34.6 degrees C. Everything was distilled off that had its boiling point below 100 degrees C. In the meantime, the bridge was isolated. When the temperature dropped after 95 degrees C, while the oil bath's temperature increased, the distillation was stopped. In the receiving flask, all solvents should have been collected which were used in the synthesis. The mixture in the distilling flask had a distinct cinnamon-like smell, which obviously covered up the traces of benzaldehyde. The refractive index of the mixture was tested to see whether it was already close to cinnamaldehyde. The value was close to the literature value, but still higher. That's why on the next day a vacuum distillation was set up. The only difference to a simple distillation is in the vacuum pump, which is connected to the vacuum adapter. The water and the stirrer were turned on before the vacuum pump. This ensures that a flash boil is not likely to happen and vapors could condense. Often traces of low boiling solvents begin to boil immediately after turning on the pump. In this case, most of these were distilled off before. Only then the hot plate was turned on. After a while, first droplets formed on the surface of the apparatus. At first, different compounds were distilled off, while the boiling point did slowly rise from 80 degrees to 85 degrees C. Then the boiling point dropped significantly before rising over 100 degrees C. At the same time, a yellow oil did condense in the apparatus, which could have been the product. So the distillation was stopped again. The receiving flask was swapped and it was noticed that the condensate had the distinct smell of benzaldehyde. This meant that the boiling point was decreased by around 90 degrees C due to the vacuum. So this had to apply to the boiling point of the cinnamaldehyde too, even though this was only a rough estimation. Then the yellow oil was collected, which had a boiling point of 134 degrees C. The distillation was slow, so the apparatus was isolated. When the temperature dropped, the distillation was stopped. To equalize the pressure, a stopper was removed very carefully and slowly. If this is done too fast, the air rushing into the apparatus could cause the compounds to splash. A yellow oil was collected which had a distinct artificial smell of cinnamon. This was due to the natural smell being caused by way more different compounds. The refractive index was closed at 1.614 but below the literature, which was why more tests were done. To determine the boiling point, some of the oil was added to a test tube with some boiling stones and a thermometer was placed above it. After that it was heated with a heat gun until the oil began to boil. It didn't reach high enough, so the thermometer was placed lower. The discoloration showed that the compound either reacted with air or did simply decompose. The highest temperature was at 213 degrees C, which was way below the literature value, but could be caused by a lot of reasons. The value was at least above 200 degrees C. Bromine water is used to test for double bonds, but in this case it could also be reused by the aldehyde group. Obviously, a reaction took place. Next, the tolerance reagent was used to test specifically for the aldehyde group. The sample was added to a solution of silver nitrate and ammonia and heated up. If the test is positive, the silver ions are reduced, leading to a silver mirror, as it can be seen here. In the end, a small sample was added to a watch glass and left to sit for a few days. If it was cinnamaldehyde, it could be oxidized to cinnamic acid, which is solid. Interestingly, the oxidized sample had a way more natural smell because cinnamic acid is one of the other compounds in cinnamon. 10.2 grams of cinnamaldehyde were obtained, which corresponds to a yield of 23%. The low yield might be due to a lot of side reactions, which can be seen by the residue in the distilling flask. This was the synthesis of cinnamaldehyde. I hope you enjoyed. Please rate and comment. A big thanks to my supporters on Patreon.